Hello, welcome to my channel. Glad you're here. So today we're gonna be looking at some challenges on lead code. I know so many programmers go through these coding challenges, and sometimes it's hard to find a job without passing these challenges. So I'm choosing to pick. I'll be randomly picking challenges, and we'll try to find a solution for them. And today I'm looking at this one, and it's a challenge that usually asked by Amazon. It's one of the coding challenges that people are looking for Amazon jobs will find in their challenges, something they will have to solve. So it's challenge optimal partition of a string. It's under the string manipulation. Yeah, it's all about manipulating strings. So when you see the problem, it says given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. It says return the minimum number of substrings in a partition. So so here they're saying not that each character should belong to exactly one substring in a partition. They provide us with a sample input S, and it has the string, so the output is 4. And the explanation is that two possible partitions are, so when we partition this string, we can get A, BA, then CAB, and A, and AB, A, CA, BA. So it can be shown that 4 is the minimum number of substrings needed. So if you count here, 1, 2, 3, 4. So our solution would be would return, our function is supposed to return an integer depending on the number of substrings we get from a string. So if we look here on example 2, this is the string, and it has similar characters. So say output is 6. That's because each character is treated as a substring. So usually when they ask this question, they're trying to see how you'll break down this problem. So software is all about solving problems. You may not know the syntax, but it's all about understanding how you break down a bigger problem. So if you look at this problem here, it's the problem is not to write the code that will generate this function. It's to think through how you're gonna break down this problem. How you're gonna break down this big problem into small chunks of problems, and then solve those problems one at a time. So our biggest issue now is to find a way of breaking down this string. How can we be able to break down this string and be able to tell that maybe this string and this string already exist? Like we need to go through this string one by one, go through each character one by one, and check if it has already been a substring has already been created with unique characters. Okay. So as a programmer, you're supposed to think, how am I going to achieve that? Which data structure can I use to achieve that? And when you talk about a data structure, you would automatically think about a hash set, because a hash set is the structure I'm talking about in terms of the C# language. I know it's there in Java or Python, whichever language, there is a data structure that only takes in unique characters. So let me open my development environment. I already created a solution here called lead challenges, and thinking as a programmer, we already know that we have to iterate through the string. We have to keep each string. We have to compare. We have to keep each character in a hash set, our data structure, and we keep on checking if that character is already there. So I'll begin by creating a public static string, a static function. I create it static because I don't want to go on creating instances when I want to access this method. So I'm using C# as a language. I know the Java developers can follow along. Syntax is almost the same. So I'll say public static. I'll call my method. We can call it string partition. Yeah, maybe something like that. Can call it string partition, and we know it is supposed to return an integer. So we expect to return an integer, and we're supposed to pass in a string str. So it's already here. It's already complaining because we have to return a string. That is okay. So how do we start? We'll use a hash set, like I said before. Up here I have a method just for demonstrating how a hash set works. It only takes in unique elements. Like you see here, we add 1, add 2, add 1. But you will only be able to, if you check this list, you only find 1 and 2. It will not add 1 again because it's a duplicate. So we'll create our data structure hash set, and we will it will take in its generic. So we'll just take in an integer, and maybe we call it unique list. Then we'll new it here. So we've already created an object in memory, and it's a reference type. So we're gonna have this to store our unique characters. Then what we'll do, we need to iterate through this string here. So we'll use a for each char c in str. So this is saying for each character in this string, what we're gonna do, for each character in our string, we're gonna check if it already exists in our unique list. So we say if our unique list dot contains c. So if our string contains this character in the string, what do we do? So we're saying, okay, so if our unique character, if our data structure contains this, we're gonna introduce a new variable int result is equal to 0. So we will increment our result. We will know that, oh wait, So we'll know, hey, in our unique list, we already have this. So that is already one substring. And then we will clear it for unique list dot clear. So we will increment and know that's our first substring, clear it for checking our next substring. Then unique list dot add, then we add our character into our unique list. I hope you get the logic here. So the whole point is to make sure that we have the unique list. This unique list will only take in a unique character. So if a character already exists in that, it will not be added there, and we will just know that it's a substring. There's already substring. So after going through all the all these characters, we'll be incrementing the number of substrings we are getting. And finally, we will check if there is something remaining in the unique list. If unique list dot count is greater than 0, we'll know that there is another substring left in the list. So we'll increment it again. Then finally, we will return our result. So our function string partition will stop complaining. Of course, for this method, we could have done a try catch or something, but I know that is that's something different, but it's recommended to always do error handling. But for the sake of the challenge, we will not be doing that. So we need to test our function. So I'll go to my main method. Already done this. In the main class, main is usually the entry point. So we'll declare here an integer. Remember, our function returns something. So, and we're not creating a variable, an object to access the method, because it's not an instance. Our class is static, so we don't need to create variables. We'll just access it through the class name. So when we select function, which is this class, and then we say dot string partition, and then pass in the character, the string, sorry. So we're supposed to get the number of possible substrings from this, and from our challenge here, this is supposed to return output 4. So I run this. So program is building. Just a minute. Okay, so it says total number of substring is 4. That is very good. That means our function is doing exactly what we expected it to do. So I'll just get this code here and try to put it here, and we'll run it again. Type definition end of file expected. This is why sometimes I don't like to use this, because it doesn't have the good compilers. It's saying line 28. Oh, here. So maybe we got one of the brackets wrong. So this one is for closing the function. This one is for closing the class. So we only need this here. Don't need to copy anything extra. So we run this again. Say the name str does not exist. Oh, so it's here. Remember, we didn't change the. So we can change the parameter to be str. Run again, and boom, accepted. Case 1. This is the input. Output is 4, and it's the expected one. That is case 1. Case 2. It's all the same. So here we can submit our solution to LeetCode and see. Yes, this solution beats 97. You see, memory. This is a very good runtime. 67 milliseconds. That is the O of N in terms of the. This is actually one of the best solutions for this challenge. Yeah, thank you guys. Please subscribe. I'll be posting more of this. This is a new channel. I'll be posting more of these challenges as we learn from each other. Thank you so much. I hope to see you in the next video.